Assalamualaikum warahmatullahi wabarakatuh. Today, my group will present about application of differentiation for our calculus 1 assessment 3. We chose applied maximum and minimum problems as our discussion. This is our group members, which is me, Fatih Shuaida, Hakim Amar, and Muhammad Shafiq. I will start the presentation with explaining what is differentiation. Differentiation in mathematics is the process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation. Using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate function. After knowing the meaning of differentiation, we need to know why we use it. We use differentiation because it allows us to find rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily.
Next, we go to the problem statement. A rectangular fish pond with an area of 60 meters square is surrounded by a flower border with 3 meter wide on 2 sides and 2 meter wide on the other 2 sides, as shown in figure above. Let x and y be the length and the width of the fish pond respectively. There are 3 problem statements in our discussion, which is, firstly, show that the combined area, which is fish pond and the flower border, is A equal to 4x plus 360 over x plus 84. Next is, what dimensions of the fish pond will minimize the combined area? And lastly, what is the minimum combined area? Okay, for the first question, show that the combined area, which is fish pond and the flower border, is A equal to 4x plus 360 over x plus 84. We use xy equal to 60, and from that we get y equal to 60 over x. So from that, the value of y, we will substitute that in A, which is A equal to 3 plus 3 plus x times 2 plus 2 plus y, and we get 6 plus x times 4 plus y, and we get 24 plus 6y plus 4x plus xy. And then we continue the operation and we get 24 plus 6 times 0 over x plus 4x plus 60. And lastly, we get 84 plus 360 over x plus 4x, and the final answer is A equal to 4x plus 360 over x plus 84. Next, I will solve the problem solution for question B, which is, what dimensions of the fish pond will minimize the combined area? So we just take the combined area of fish pond and flower border, which is A equal to 4x plus 360 over x plus 84. So we get dA over dx equal to 4 plus 360 over x square. Then we need to equal the differentiate equal to 0, because we want to calculate the minimized combined area. So after we take the differentiate equal to 0, we get the new equation, which is 4x squared plus 360 equal to 0. Then we need to find the value of x using a quadratic equation. So we get x minus 9.4x68 times x plus 9.4x68. Then we get x equal to 9.4x68. We can take the negative value because area cannot be negative. Then we take the equation y equal to 60 over x. After that, we substitute the value x into the equation. We get y equal to 60 over 9.4x68. So we get y equal to 6.3246. Next, I will answer the problem solution for question C. The question is, what is the minimum combined area? How can we calculate? We just take the combined area of flower border and fish pond, which is A equal to 4x plus 360 over x plus 84. What we want to do, we just substitute the x that we get from question B to this question. So we get 4 times 9.4x68 plus 360 over 9.4x68 plus 84. Then we get the final answer 159.8947 cm square. That's all for problem solution. Next, I will conclude our group discussion. The conclusion is, based on our group presentation, we have proved that differentiation, minimum and maximum problem can help us to solve the math problem in finding dimension of the fish pond that will minimize the combined area with flower border. It also help us to calculate minimum combined area of the fish pond and the flower border. In conclusion, differentiation help us to solve the real life calculation problem that includes area and minimum area. So that's all from us. Thank you.